Hi everyone, and welcome to part 2 of the series where we are solving simultaneous equations via elimination. So over here we have two equations. Let's go ahead and label them as usual. So let's go label it 1, label it 2. And now we see that these equations, they seem a bit more complicated because of all the fractions. But actually, there's nothing to fear. The first thing I want to do is maybe I don't really like the way it's written as mixed fractions. So actually, I'm going to rewrite equation 2. I'm going to write it as 2 over 5x minus y over 6. And instead of 2.5, I'm just going to rewrite it as 5 over 2. Okay? And then I'm just going to say, I'm going to label this as 2 instead. Well, I didn't really do much. I just changed the mixed fraction into an improper one. And so we look at the two fractions now. The two equations now, equation 1 and equation 2. And we want to make one of the numbers the same, but we see all the fractions and it seems a bit complicated. So how about we try a different strategy? This strategy is trying to make one of the variables be not a fraction for both equations. That means, let's say, for y, let's maybe try to make y in both equations no longer be a part of a fraction. How do we do that? So for equation 1, we would have to take equation 1. Now it's y divided by 3. So if we took equation 1 and we multiplied it by 3, the fraction for y would go away. So it would look like this. X over 2 minus y over 3. Whole thing multiplied by 3. Of course, you multiply the right-hand side by 3 as well. The 3 multiplies in, so this will be 3x over 2. Now 3y over 3, you can see the 3's cancel out, right? Because 3 divided by 3 is 1. And of course, 4 times 3 is 12. And there you have it. We have 3x over 2 minus y equals to 12. Now let's call this equation 3. Now this came from equation 1, right? And so now let's find a version of equation 2 that enables us to have y be not part of a fraction. So this is y divided by 6. So simple, let's just take equation 2 and we multiply it by 6. So we say 6 and then we multiply it by the left-hand side. Now if you are getting lost by this point, I think you should go back and watch part 1. I think then it will be a lot clearer for you. Otherwise, over here, you can see multiply both sides by 6. You multiply in 6 times 2 over 5x will give me 12 over 5x. Now 6y over 6, once again, the 6's cancel. And this gives me 30 over 2, which actually equals to 15. And so let me rewrite that again. This is equation 4. Once again, equation 2 became equation 4. So now we are really solving equation 3 and equation 4. How do we solve it? Well, we can see very conveniently now that the coefficient of y is exactly the same. So when we have the coefficient exactly the same, we just take equation 3 and we subtract equation 4 from it. Okay, so let's try that and let's see what we get. So we have equation 3, 3x over 2 minus y. And then now we subtract equation 4 from it, 12 over 5x minus y. And we see that this equals to, once again, 12 minus 15. And very conveniently, we will see that when we expand it, of course the negative sign goes in, right, the negative sign gives me a positive y. 12 minus 15, negative 3. Wow, this, we can see over here, they cancel out. Plus y, positive y minus y gives me 0. And so y's are gone, 3 x over 2 minus 12 over 5x equals negative 3. Now don't let this confuse you. Actually, we can just write this as 3 over 2x. Now I went through this in class, so if this confuses you, yeah, you can try to find out how come I can write this as this. And then now we take 3 over 2 minus 12 over 5x equals a negative 3. So let's simplify the x. 3 over 2x minus 12 over 5x equals negative 9 over 10x, which is equals to negative 3. And so both sides are negative. What we can do simply is multiply both sides by negative 1, right? Well, whatever we do on the left, we do on the right. There's no problem with that. We flip the sign for both sides, we get positive 9 over 10x equals to positive 3. And then next thing, we multiply both sides by 10. That's how we get rid of the denominator. And we end up getting 9x equals to 30. And x is equals to 30 divided by 9. And so that gives me x equals to 30 divided by 9 is simply 10 over 3. And so we have it. We've solved x. So what do we do next? We simply substitute this value of x into really any of the equations that we've had. So let's just pick equation 3. So let's use equation 3, and remember what was our x value? It was 10 over 3. So equation 3, x is equal to 10 over 3. So let's say it's 3x times 2, so 3 times 10 over 3. 3x divided by 2, so 3 times 10 over 3 divided by 2 minus y equals to 12. So let's just move or add both sides by y, and so we get 10 over 3 over 2, and we get 12 plus y. Let's simplify this. 3 times 10 over 3, this 3 actually cancel out, so this is actually 10 over 2 equals to 12 plus y, and then 10 divided by 2 is 5 equals to 12 plus y, and then y finally is equals to 5 minus 12, and y equals to negative 7. So voila, we conclude that x equals to 10 over 3 and y equals to negative 7. There you go.